Factoring sheet. Pick one or two problems from your factoring review that you would like me to work out for you. And I will be happy to do that. Awesome. Finished?
Yes.
Okay, cool. One or two problems factoring review. Anyways, anybody go?
42.
42. Let's do number 42. I think that's the very last one, right?
Yep.
Okay. So number 42. So this is your factoring review sheet. So here's kind of how I do this. Number 42. The first thing that I'm going to do is I want to see. So this is your packet that I gave you yesterday that I said I would give you time until Monday, even though it was supposed to be due today. I'm going to give you till Monday. We should have time in class to work some out together. So I wanted to start with that. Pardon me? What if you stay up until 2 a.m. doing what? You just wanted to get it done? Yeah. Kudos for you, but I did tell you that I'd give you an extra day. So, okay. So here we go. Let's see. Is 154 divisible by 6? How do you know? Can I tell you how you know? Without using a calculator. There's a trick. What is 1 plus 5 plus 4?
9, 11.
From the review packet from yesterday? Yes. 1 plus 5 plus 4 is 10. Is 10 divisible by 3?
No.
No. If it's not divisible by 3, then it's definitely not divisible by 6. The only way that a number is divisible by 6 is if it's divisible by 2 and 3. Meaning it's got to be even and divisible by 3. So is this divisible by 6? No. It's not divisible by 3. So we can't take a 6 out. That means we also can't take a 3 out because it's not divisible by 3. But what could we take out of there as a GCF? This is problem number 42. I just said I would start off with problem number 42 from your packet. I'm looking, Miss Ella, I promise. I don't know where I put them. So what else? What else can I take out? A 2 and possibly what?
4.
A what?
4.
Maybe a 4. Yeah. Is there anything else I can take out? In. There's a variable term I can take out. I know that I have tons of those printed from yesterday. Ella, you know what? You're just going to have to hang tight for a second. I don't know where they are. Poop on a stick. I know I've got them. I just don't know where they are. So write this down on a piece of paper, and when I print it, I'll fill it out for you. Okay, so we're going to divide everything by 2. You think it's divisible by 4? Well, let's see. If 4 goes into 15, 4 goes into 15 3 times with 12, that leaves me with 34. Is 34 divisible by 4? No. So we can only take out a 2 in. That's just it. 2 in, 2 in, 2 in. So once I take that greatest common factor out, I put it down at the bottom because if I don't include it in part of my answer, I forget it. I just do. That's just a bad habit of mine. So let's see. 60 divided by 2 is 30. N cubed divided by n is n squared. 154 divided by 2 is negative 77. And n squared divided by n is n. 24n divided by 2n is just a positive 12. I feel like we did this problem yesterday. Someone got this right. So let's see. I have to do my times plus chart. Okay. You got this one? So 30 times 12 is, zip it, 30 times 12. Well, 3 times 12 is 36. So 30 times 12 is 360. Has to add up to, so remember the times, A times C has to add up to B. B is negative 77. So let's see, I'm looking at factors of 360 that add up to negative 77. So if you don't see factors right off the bat, how can you do that? Yeah. In your calculator, y equals 360 divided by x. And I'm looking for, then I go to the table, and I want 2 numbers that are going to add up to negative 77. Let's see. Negative 77. That means that I'm going to have some, 72 and 5. And it's going to be a negative 72. And a negative 5, right? So the way that we factor this is we are going to replace this middle term. This is called factor by grouping. We are replacing the negative 77n with the negative 72n and the negative 5n. I didn't really change the problem. This 30n squared does not change. And the plus 12 doesn't change. And if I were to combine like terms, negative 72n and negative 5n equals negative 77. So what do I gain by doing this? I have 4 terms, and it lets me group them. And that's what I'm going to do. So I'm going to factor by grouping. So let's see. I could take out what from the first term? What can I take out of that first term when I group it? Well, factors of 30. Let's see. 1 and 30, 2 and 15, 3 and 10, 4 and not 4. What about 6? 6 and 5. These are both divisible by 6. And they're also both divisible by n. So I'm going to take a 6n out of my first parenthesis. What can I take out of my second one? Is 12 divisible by 5? The second grouping, what can I take out of this? What can I divide both of those terms by? Nothing. 5 is not divisible by 6 and 12 is not divisible by 6. I have to take something out. So I'm going to take out a 1. And I know from just doing this problem that it's going to be a negative 1. I'm going to take out a negative 1. I'll show you why in a second. Okay. So let's see. 30n squared divided by 6n is 5n. Okay. And negative 72n divided by 6n is negative 12. Remember, I told you guys yesterday when we did practice problems, you need to have a copycat. If you're going to factor by grouping, that term that the term in the middle has to repeat itself. So I'm going to take out a negative 1 here, and that allows me to say negative 5 divided by negative 1 gives me a positive 5n, because these two have to match. And 12 divided by negative 1 equals negative 12, because this term and this term are what we call copycats. They have to be the same. So you take your copycat and you pull it out first, 5n minus 12. And then you look and say, what do I have left over? That gets put in the second parenthesis. Well, your leftovers, 6n minus 1. So this is number 42 factored all the way. Okay. I know you want to vomit. I can tell by the, I can feel it. Let's do something like 41 or 40 or one of those weird ones that have like these quantities squared. Pick one, Zach. 41. I think that's a good problem to do. So let's do 41 together. So I want you to think about when you learned how to FOIL. 3x plus 1 is the same thing as what? What does 3x plus 1 mean? Anyone? I'm trying to send this to the printer for Miss Ella. What's 3x plus 1, the quantity squared, mean? What does that actually mean? It means 3x plus 1 times 3x plus 1. So that's what I have to do. So we're just going to write that as a product. Ella, I'm sending this to the printer right now. It's going to take 17 minutes because the printer sucks. But anyway, so 3x plus 1 times 3x plus 1. So that takes care of this term. What does this mean to do? Negative 12. It means to distribute, right? So that we can do like in our brains, right? Negative 12 times 3x is negative 36x. And negative 12 times 1 is negative 12 plus 20. So this is what I have to FOIL. Let's see. 3x times 3x is 9x squared. 3x times 1 is just 3x. 1 times 3x is 3x. And 1 times 1 is, okay. So we have to do some combining of like terms. So I always start with the largest agreed term first. 9x squared. There is no other x squared, so I'm going to pull that out first. 9x squared. Okay. Now let's look at my x's. I have 3x plus 3x, which is minus 36x. What's 6 minus 36? Negative 30x. Okay. And then I have a positive 1 minus 12. What's 1 minus 12? Negative 11 plus 20 is positive 9. Okay. So is there a GCF in this? 3. Let's take a 3 out of everything. Divide by 3, divide by 3, divide by 3. So I'm going to pull that 3 out first. Otherwise, if I don't write it, I'll forget it. So that 3 is going to come out. And let's see. 9 divided by 3 is, so 3x squared. Negative 30 divided by 3 is, and 9 divided by 3 is positive 3. Times plus chart. Times plus. To figure out the time side, I have to take A times C, which is what? 9. Has to add up to negative 10. What two numbers do I multiply together to get 9? That when I add them, I get negative 10. Negative 9 and negative 1. Yeah. Those are the two factors that I'm using. I have to group this. So I have 3x squared minus 1x minus 9x plus 3. So all I did was replaced this negative 10 right here with the negative 1 and the negative 9x. It still has the same value. I do that so I can group these and look for a GCF. So what's a GCF in that first grouping? What can I divide? What can I take from both terms in that first grouping? An x. I can take out an x. Take an x from that and an x from that. So when I take the x out of that first term, what do I have left? 3x minus 1. Okay. What can I take out from that second grouping? A negative 3. Yes. I want to take out a negative 3. So I take that negative 3 out, and then I say what's left? Well, negative 9 divided by negative 3 is positive 3, and I bring down my x. And a positive 3 divided by a negative 3 is a negative 1. So what do I have? Well, I have a copycat, which has to go together in the first blank, 3x minus 1. And then you take what you have left over and you put it in the second parenthesis. My leftovers are x minus 3. So this is what number 41 is, completely factored. That is number 41, completely factored. I'll do one more and then we're going to do notes. I'll do one more and then we're going to do some notes. Pick one.
38.
Which one?
38.
38. Are you going to write it down? Because you didn't write down 41 or 42. You already have them both done? Do you have them correct? What does that say? You do have them correct. Good job. Okay. Shh. Dustin, which one did you want to see? Between 35 and 38. Pick one. Yep. 38. Here we go. That's what I'm doing. 38, 38. Okay. Is 38 a tough one? Because I gave my answer key away. 38. We got this. Okay. What does it mean when I say y plus 6 the quantity squared? It means y plus 6 times y plus 6, right? Okay. That's all right. Do you guys remember you learned how to FOIL these as special cases? You square the first term, y squared. You take, to get the middle term, the term in the middle, it's 2 times the first term times the second term, which is 12y. And then you square the last term. That's how you learned how to do that. It was called a special case. You can FOIL it out or you can use the cheat. Then we're going to distribute this guy right here. Let's see. -3 times y is -3y. -3 times 6 is -18 minus 10. I always start with my largest degree term because that's what's got to come first. And I look through to make sure I don't have any more. So do I have anything other than that y squared? Nope. So y squared. Cross it off. Now let's combine all our y's. I have a positive 12 and a -3. Positive 12 and -3 equal positive 9y. Then I have a positive 36. I'm going to get rid of these. Positive 36 and a -18. 36 take away 18 is minus 10 more is plus 8. Okay, times plus. What two numbers can I multiply together to get an 8 that when I add them I get a 9? And the cool thing about this is when a equals 1, the factors that you choose are the factors that you use. What can I multiply together? 8 and 1. 8 times 1 is 8. 8 plus 1 is 9. So my factors are y plus 8 times the quantity y plus 1. And that's it. What are you thinking about that? That turned out easier than we thought it was. You still don't like it? Okay. Well, I'm sorry that I can't make you like it. So let's go to our notes. So today we're going to start off with simplifying rational expressions. And I'm going to try to go nice and slow. And then if we have more time and you guys want to see more of the practice, the unit review of factoring, I will be happy to do that. Okay, so we're going to simplify rational expressions. And it says that in order to simplify rational expressions in their lowest term, we want to be able to factor them, right? We want to be able to turn them into factors. So we're going to start off with something really basic, like 18 and 12. If I was asked to write 18 over 12 in simplest form, what would you do? Writing it in simplest form. So that means I have to do what? No, I want you to write the fraction. It's
18 down to 2, and then it would be
hang on a second.
down to 33.
Okay, so what are you dividing by? Tell me what you're dividing by. You're dividing each term by 6. Good job. I'm going to divide the top and the bottom by 6. What is 6 over 6? 1. Dang it. So am I changing the problem? No. Dividing by 1 doesn't change the problem. I'm just going to make it look different, right? 18 divided by 6 is 3, and 12 divided by 6 is 2. Awesome. Okay. So when you look at the next example, x squared minus 9 over 2x plus 6, I again have two fractions. I can write those as two fractions. Let's factor out the first. What's the numerator look like? This is the difference of squares. Difference of squares. We factored those yesterday. So if I have the difference of squares, I take the square root of the first term, which is what? What's the square root of x squared? It's x. And what is the square root of 9? So we factor this as x plus 3, x minus 3. That's how we factor that. Let's look at the 2x plus 6. What can we do with this, 2x plus 6? We can pull a 2 out. So if I take a 2 out of the 2x plus 6, if I factor out a 2, let's see, it becomes x plus 3. And so now you see that you have the same thing in the top as in the bottom. And I want to show you what I mean by that. So I'm going to use Jack's idea of instead of dividing by 6, I'm going to rewrite this expression over here. I just want you to understand the math. So 18 over 12 is the same thing as 6 times 3 over 6 times 2. Correct? I mean, that really is what 18 over 12 is, 6 times 3 and 6 times 2. But since I have a 6 in the top and a 6 in the bottom, those cancel out. So when you look over here, I have x plus 3, the quantity in the top, and I have an x plus 3, the quantity in the bottom. So those cancel out. So what are you left with? Over 2, right? Does that make sense? Over 2? Okay. So I'm going to show you some voodoo math, things that I see kids do. Don't do this. I don't even really know how to spell voodoo. I'm spelling it like this. It's probably wrong. Don't correct me. I don't care. Let's see. This is what I see kids do. X squared minus 9 over 2x plus 6. So I see this all of the time. Again, this is not correct. Let's see. 9 divided by 3 is 3. 6 divided by 3 is 2. I can take an x out of here and an x out of here. And both of these are a 2. So 2 plus 2 is 4. That's my denominator. And I have x minus 3 in the numerator. Not even close, right? This is voodoo. This is not right. This is a big fat no. And I want to explain to you why. You can simplify expressions when they're joined by multiplication. You cannot simplify expressions when they're joined by addition, right? You can't just take part. You can't take part of this. You can't just pull a 2 out of this side. You'd have to pull a 2 out of both terms because they're joined by addition. You can't just take an x out of this side, out of the x squared, because these are joined by subtraction. So if 2 terms are joined by addition or subtraction, you cannot just pull something from one of the terms. You have to take the greatest common factor out of both. That's why this is voodoo. It doesn't give you the right answer. This is how you do it. I just want to show you, I see this. I just gave it kids for some kids on factoring, and this is what I got. So this is not right. Okay? That's voodoo math. Don't do it. Okay, let's do the next one. I know it's hot in here, you guys. I know it's hot. I've got the window open. I'll bring a fan in because I know it's hot. Well, I'm not going to shut the window because it's sweltering and my period 4 class is stinky. So, I mean, they just are. They come from gym. Like half of them come from gym. It gets so over the top. Like, you know what I'm talking about. I don't even know why I'm trying to explain that. Just overwhelming BO smell. Okay. So every time we simplify a fraction, we're essentially finding all of the common factors. So I want to remind you that you did this in Math 1 when you learned about exponent rules. Okay? When you learned about exponent rules. So I'm going to do this first one really, really, really basic. And if it's too much for you, I apologize. And I'm going to do my best to write neatly without having a really good stylus. So I'm going to simplify the numerator first. So the numerator is 3. X to the 5th means x times x times x times x times x. And y to the 6th means y times y times y times y times y times y. That's really what the numerator means if I break it down into prime factors. Chris, open your eyes and pick up your pencil or you're going to come stand by me. Let's look at the denominator. Okay, 6, when I think of prime factors, is made by taking 2 times what? 3. X to the 8th is x times 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 x. 1, 2, 3, 4, 5, 6. Okay. And then y cubed is y times y times y. So you learned a rule when you learned to simplify exponents. And the rule said that if the base is the same and you're dividing, you subtract. I'm going to show you what that rule means. So you just, first of all, simplify this. 3 divided by 6 is the same thing as 1 over 2. I want you to look at this expression right here. Is the base the same? Is x to the 5th and x to the 8th, do they have the same base? What is it? X. Okay, it's a division problem, right? So that means that we're going to subtract the exponents. Are there more exponent powers in the top or in the bottom? The bottom. How many more? That means they stay down there. Now I want you to look at the y to the 6th power divided by y cubed. Is the base the same? 6 minus 3 is? Are there more powers in the top or in the bottom? So that's where it goes, y cubed. Now I want to show you why that works. Let's see. 3 divided by 3, those can cancel out. I can take out an x, an x, an x, an x, and an x, and I'm left with 3 x's, which is x cubed in the denominator. And I can take out 1, 2, 3 y's, and that leaves me with 3 y's, y to the third power in the numerator. So this is y cubed over 2x cubed. Now, again, I don't want you to do it this way every single time. Are you kidding me? That's horrendous. I don't want you to do it like that, but I want you to know where the rule came from, okay? So the rule is when you're simplifying rational expressions, you're going to divide constants, those are numbers, like normal. Divide your constants like normal. And then if the base is the same, use the rule of subtracting exponents. So 20 divided by 4 is what, Chris? Chris, come stand by me. Come on, let's go. 20 divided by 4, Jack. 5. Chris, come up here. I just cleared your spot. Come on, right now. 5. Stop. Come on. I'm not asking. Come on, get up. Stand up. Let's go. You're wasting everyone's time. Move up there. I cleared you out of spot. You're gonna stand right here by me. Perfect. Okay, let me get behind you. Thank you. Okay, so now let's look at, you got to be able to write on your notes. Okay, so let's look at the x's. I have an x 10th in the top and an x squared in the bottom. Are there more powers of 10 in the top or the bottom? Are there more powers of x in the top or the bottom? The top. You have 10 powers, like x to the 10th in the top and only 2 in the bottom. So 10 minus 2 is 8, and it's going to stay in the top. And then that y to the 8 is already in the numerator, so it just stays there because there's no y term in the bottom. So we've essentially canceled everything out of the denominator. When you cancel everything out of the denominator, what really lives down there? A 1. We just don't write it. So you really just have 5x to the 8th, y to the 8th. Okay? Does this make sense? Okay, so let's look at the constants in example C. 7 over 21 reduces to what? 1/3. So I'm going to have a 1 up here and a 3 down here. So I have x cubed over x to the 5th. Are there more powers of x in the numerator or the denominator? The denominator. What is 5 minus 3? So those 2 powers of x are going to go where? In the denominator. So y to the first power, I'm going to put a 1 there so you can remember that that's to the first power. We don't write it, but it does have an exponent of 1. And y to the 8th. Are there more powers of y in the numerator or the denominator? How many more? 8 minus 1 is, so that y to the 7th goes down here. And so we end up with 1 over 3x squared y to the 7th. 1 over 3x squared y to the 7th. Questions? In my bag. Or this right here. It's not been opened. Okay. So let's look at this next one. So let's simplify the constants first. So 10 over 15 reduces to what? 2/3. Good job. Are there more powers of x in the numerator or in the denominator? How many more? So x to the 4th right there. Are there more powers of y in the numerator or the denominator? How many more? There you go. So what's my answer? Number 3. Are we getting this? Okay. Jack, are you getting this? Because you're pretty busy on your computer over there. Thank you. Okay. Thank you. So those that last set of examples didn't have any trinomials in it, right? Didn't have any polynomials that are joined by addition or subtraction. These do. So I just want to kind of tell you what kind of problems these are. So this first one, A, well, here's what I know. I know that the leading coefficient is 1 in the numerator. That means that the factors that I choose are going to be the factors that I use. And I know that the denominator is a difference of squares. So let's see if we can factor the numerator first. So when I think about my times plus chart for the numerator, sorry about that. Ooh, I'm getting too close to the edge. Times plus. What are two numbers? 1 times 14 is negative 14 that multiply to negative 14 and add to 5. Positive 7 and negative 2. So that means that my numerator is just going to be x minus 2 over x plus 7. So that only happens, remember, when your leading coefficient is 1. That's the only time that works. If there's another number attached to the x squared, you have to factor by grouping or use a factor box. Tell me about the difference of squares. When we factor difference of squares, we just take the square root of the first term. What's the square root of x squared? X. And what's the square root of 4, the second term? 2. And we join each one of these factors, one with a plus and one with a minus. One with a plus and one with a minus. Okay? So is there anything in there that I can cancel out? Yeah, I can take an x minus 2 out of the top and out of the bottom. So when I completely factor this, I end up with x plus 7 over x plus 2. Okay? What kind of problem is B? What kind of problem is B? Huh? B is a binomial. B is a binomial. What is the numerator on B? Numerator on B is a difference of squares, right? Both of those are perfect squares. And the denominator is just a GCF. It just has a GCF. So let's factor the difference of squares first. What's the square root of 4x squared? 2x. So I have 2x and 2x leading both of my binomials. What's the square root of 1? 1. So I have 2x plus 1, 2x minus 1. It doesn't make a difference which one you put as plus and which one you put as minus. What's the greatest common factor in the denominator? 5. When I factor out a 5 from the denominator, I'm left with 2x minus 1. Is there anything that you see you can cancel out? Yeah. So I'm left with 2x plus 1 over 5. All right, example C, a little bit harder because A does not equal 1. A is greater than 1, right? So when we think about our times plus chart, 3 times 4 is 24, and it has to add up to 14. So what two numbers can I multiply together? Thank you. 12 and 2. 12 times 2 is 24, and 12 plus 2, right? Does that make sense? So we have to factor this by grouping. 3x squared. And then I have to use these two numbers, positive 12 and positive 2, plus 12x, plus 2x, and then plus 8. So I really just replaced the 14x with 12x plus 2x. Same value. It has the same value. I just changed the way it looks. So let's factor this. What can I take out of the first grouping? 3x. What can I take out of the second grouping? A 2. When I factor the first grouping by a 3x, I'm left with 3x squared divided by 3x is 1x. 12x divided by 3x is 4. When I take the positive 2 out of the next grouping, 2x divided by 2 is 1x, and 8 divided by 2 is 4. Do I have my copycat term? Yes, what is it? X plus 4. And then you take your leftovers and you group those together. What are my leftovers? 3x plus 2. Does that part make sense? Yes or no? Okay. So now we have to factor the denominator, and the denominator is a difference of squares. A difference of squares. So let's see. What's the square root of x squared? X times x is x squared, right? What's the square root of 16? 4. So we have x plus 4 and x minus 4. Do you see that we have a common term in the numerator and in the denominator? Yeah, cancel those out. So my final answer, 3x plus 2 over x minus 4. Sliding it up for those of you that are not able to see the bottom of it. Okay. So this next epiphany kind of thing, I wish that my teacher had like let us do this. When I went through these notes, I'm like, oh my God, this is the coolest thing ever. But my teacher made us change the order and factor out a -1 every single time. This is super cool. So we're going to come up with a rule for this. What is 9 minus 6? What is 6 minus 9? So what does that equal? -1. Cool. What is 15 minus 3? And what is 3 minus 15? And what does that equal? Okay. What am I doing with the denominator and the numerator? How are they different? Well, yeah, but look at the expressions. How are the expressions different?
They're switched.
Yeah, I just switched them, right? Instead of 9 minus 6, I did 6 minus 9. We know that that changes the answer. So when I look at this a minus b over b minus a, just think of this as like a capital A over a capital what? Negative A, right? That's how we get this -1. Does that make sense? So here's what I want you to think about. Anytime you have two terms that have the exact same numbers in them, but they're just reversed, just cancel them out and put a negative out there. It's just negative. Instead of having to like change the order and factor out a -1, this is so much easier. So let's do this first example. So I have 2x minus 10 over 25 minus x squared. What can I take out of the numerator? A 2. If I factor a 2 out, I'm left with, let's see, 2x divided by 2 is x, and -10 divided by 2 is perfect. This bottom one is a difference of squares. What is the square root of 25? And what is the square root of x squared? It's x. So do I have two terms that are exactly the same, except I've just changed the order of the numbers inside of the term, or do you guys see this?
Yeah.
So we're going to cancel this out and do what with it? Just put a negative out front. That's it. I just made the 2 negative. So I could make the 2 negative and write it as -2 over 5 plus x. I could make the denominator negative. If I do that, I have to make sure that I distribute that, right? So I either leave the negative outside of it, or I write it as 2 over -5x minus x. But I think that we're just matching it, and I think that we have this as an answer, don't we? No, we don't. Do we have this as an answer? No. Do we have, where is our answer? Oh, yeah. Thank you. I just put this on the bottom. Thank you. Thank you. Thank you. So your answer is number 1. So we're going to kind of do the same thing again. This is one of those special ones that I said, like, this started out as x minus some number squared. X minus some number squared. That's what this was originally. So what's the square root of 9? 3. This really came out as x minus 3, the quantity squared. It was really x minus 3 over x minus 3. That's what it looked like originally before we FOILed it out. And that makes sense because -3x and -3x give you your -6x. What's the GCF that I can take out of the denominator? A 6. When I take out a 6, I'm left with 3 minus x. So do we have a 3 minus x and an x minus 3 that we can get rid of? Yes. And when I do, that just means that I have a negative somewhere. So I'm going to leave it off to the side. I'm not going to actually put it in the numerator or the denominator. I'm just kind of leaving it off to the side of the fraction. So where could I move that? Where could I move that to match one of my problems? Well, notice that none of my denominators are negative. So it has to get moved up to where? The numerator. So negative times x minus 3 is actually negative x plus 3. All of these are over 6. And is there another way to write negative x plus 3? Sure. 3 minus x over 6. And I think that that is number 4, right? So you're just kind of manipulating the way that the problem looks. Just remember that if you have two binomials that have the exact same numbers in them or variables, they're just in the opposite order, just get rid of both of them, cancel it out from the numerator and the denominator, and throw a negative out there. Okay? So your guys' homework is pages 3 and 4. Your homework is pages 3 and 4. Yes, you may, sir. Thank you. Pages 3 and 4. And I think I wrote that in your